The purpose of this video is for you to be able to establish patterns within the electromagnetic spectrum. Now, spectrum is a great word, and it comes up a lot. And spectrum, a lot of times, means like a range of values, that accepted values. Like many values fit for it, and there's a sort of a grayness to it, where it begins and where it ends. Now, this spectrum is for electromagnetic waves. And what an electromagnetic wave is, it's a particle and a wave that as it moves, it generates an electrical field and a magnetic field. Now, these fields are perpendicular to each other. So the green field is actually in the plane of the screen, and the red field is going back into the screen and coming out at you. Now, the electromagnetic spectrum is those waves, the previous page, from radio waves to microwave to infrared to visible light to UV and X-ray, all ending at gamma. Now, radio waves are the weakest of them. Gamma are the strongest. Radio waves have the largest wavelength. These guys have the smallest wavelength. Radio waves have the lowest frequency, and gamma rays have the highest frequency. And as you move across the electromagnetic spectrum like this, the wavelength goes down and the energy and the frequency go up. Now, all of these things are called light. We call the middle part of the spectrum visible light because that's what we can detect with our eyes. And they all travel at the same speed. And that's 3 times 10 to the, or 3e to the 8th meters per second. And this is often written as c, the letter. C is the speed of light. Now, these things can transfer energy. These waves can transfer energy to matter. When you stand outside a stove and you can feel the heat, it's when that is infrared radiation that you're being hit with, and it's radiation heat from something that's hot. All of these waves are given off by matter as well. So here we've got a radio tower. That's the source. It's giving off radio waves that are being picked up by this boombox. Now these waves don't need a medium to move, and a medium is something that the wave can move through. The best example for this is all the light that travels to the Earth doesn't move right ahead, it just moves through empty space. Now all this light travels in photons, and a photon is like a packet of energy. If you look at a light bulb or you look at a light, it's not like there's this long wave that's coming to you to hit your eye. It's not a rope. It's really this quantized little packet that's moving towards your eye really quickly. So you're really seeing lots of them over any given moment of time. It's almost like the water molecules of rain.